Here we want to start to look at the energy that's involved in phase changes. So you may have or may not have already done the heating and cooling curve experiment. If you look at the heating and cooling from a theoretical standpoint, and what would happen, you would get the graph on the left. So this would be typical diagrams for the cooling of a liquid. So we know that if we take energy away from that liquid over time, that the temperature would go down. So that's where we've got this transition from A to B, where we're removing energy from those liquid particles, slowing them down. So we observe that as temperature going down. However, now we need to think a little bit about what's happening from B to C. So there, the temperature is not going down, and yet we are removing energy. Again, as time goes on, we're removing energy from the substance. So how is that substance responding to that decrease in energy, or that energy being removed from points B to C? And that's where we get our change of state happening from liquid to solid. And so what we're doing is we're rearranging the particles during that part. So that taking away of energy is causing the particles to rearrange themselves to a lower energy state, although they're not moving any slower. So the kinetic energy of the temperature, the temperature's not reflecting a change in the kinetic energy. Once we get to point C, now we have all of the liquid has been converted to solid, and then from C to D, we would then have a decrease in the kinetic energy of the particles, which was reflected in a decrease in the temperature. So it would be the energy coming out of the solid state particles. If we look over on the right, this is a typical cooling curve that we might observe in the lab. Notice that the lines aren't quite as precise for us, but we still have that general decrease that's happening. Some sort of a plateau that's occurring in here, stirring, just not getting particles, reflecting a good decrease in temperature. All that kind of stuff is factoring into not having a perfect plateau there. And then we've got the slow gradual decrease afterwards, which could be a result of the difference in temperature between your substance and your and the water bath or whatever you have around it is starting to become closer in temperature, so the heat's not being removed quite as quickly over time during that part. So you get a much more gradual decrease there. The significant part here, though, is that temperature at which the plateau is happening, which would be reflected, or which would reflect the temperature at which the substance is freezing. You also want to think about these curves in terms of both the kinetic and potential energy of the substance that you're observing, and then thinking about what's happening to the kinetic and potential energy during each of those parts. So we'll talk more about this, and we'll do it from a quantitative standpoint and try to actually figure out how much energy needs to be removed in order for these transitions to happen in another video.